Hey everyone, as promised, I am back. Okay, so we're gonna try to finish up on everything. So where we left off, just kind of do a quick review. All right, so we were talking about inscribed triangles, but we were really looking at the inscribed angles. So inscribed angles is different from central angles. So central angles is when your vertex is at the center of your circle. But in this case, our vertex is on the circle. So that angle is made with the vertex that's on the circle. When you have it like this, the angle measure is half the measure of its arc. All right? So if they give you the measure of the arc, you're going to take half of that to find the angle measure. Okay, so this is what's called an inscribed angle. So let's do it by looking at a couple of examples. So we're on to this one. So when we have this angle measure of x, y, z. So the angle measure is 23x minus 2. So if you notice, I'm going to kind of make this a little more predominant. So if you notice this side, I have an endpoint here at x. I have another point here at z. So that's telling me that this arc here is basically going to be twice as much as the measure of this angle. So I know a lot of people are going to be like, well, wait, Audrey, isn't that like a half circle? So wouldn't that be 80? So couldn't we just say, oh, that's going to be 180 equals this? Now careful. So we know that this is a half of a circle. So it will be 180 degrees, but it's not just going to be this is going to equal 180. It's not the central angle. It's the inscribed angle. So with it being an inscribed angle, we know that this is going to be half of what goes on in here. So we can design it like this. We can say, let me unzoom a lot so I can give myself some room. So we can say this 23x minus 2, because that's the measure of the angle. If I double this, it will equal my arc. So I'm going to times this by 2, because remember, the angle measure is half its arc. And we can clearly see that the arc, because of x and z, is showing that it's going to equal 180 degrees. So we're going to have it equal 180. Or, as someone mentioned, I think it was Kate. Yep. So Kate is thinking that it's going to be a right angle. Because if this whole thing is 180, half of it will make that equal to 90. So if I want to, instead of doing the distributive property, I can simply do this. I can divide both sides by the 2. So now I have 23x minus 2 is equal to 90. And now I can go and solve for x. So if I add 2, That means I have 23x is equal to 92. Excuse me. So if I have my 92 and I divide it by 23, I think it'll give me 14. No, wait, 4. Okay, so now I found that x is equal to 4. Yes, Tisha, good. All right, so if x is equal to 4, I'm not done. I want to find that measure. I'm going to slide over a little bit. I'm going to find the measure of this angle x, y, z. If it just said solve for x, boom, we're done. Okay? But if I want to find the measure of that angle, because usually it tells me it. If I want to find the measure of angle x, y, z, I need to plug it in. So I'm going to plug that 4 in for the x. All right. Thanks, Kate. She's like, not done. I'm like, no. If it says solve for x, then boom, we're done. But if we want to find the measure of x, y, and z, we just have to plug it in. So 23 times 4, that gives us our 92. Hence, that's what we got. And you're like, wait, didn't it just take us right back to what we were doing? I'm like, yep. So we didn't have to do all of this, because didn't it take us right back to our 90? Because once we figured out the measure of this arc is 180, and we know that this is going to give us, that half. It can give us 90 if I'm looking for x, y, and z. If I just want to find what x is, yes, I want to do all the work. If I want to find the measure of that angle, I could have stopped at 90. Okay? But here's the thing. It didn't tell us what to do. Right? It didn't tell us. If it said solve for x, yes, boom, you're right there, you're done. Okay? If they wanted us to find out the measure of that angle, then we can go ahead and find the measure of the angle. All right? Okay, so this time, I want to figure out what x equals. Okay, so for the next one, I want to know what x is going to equal. So let me zoom in so you can see it a little bit better. Okay, I want to know what x is going to equal. Oh, because we were able to calculate it, Sid. So here we have a chord that's going through the center of our circle. So this chord is called the diameter. So that's going to be half the circle. So that means since this is the center of the circle, this is 180 degrees because this angle is 180 degrees. So for inscribed, 180 degrees, half of it is going to be 90. Your inscribed angle is always half your arc, as I have shown here. Your inscribed angle, which is angle C, is half your arc, which is AB. Okay. So just because they don't necessarily give you that little indicator that it's 90 degrees, you can find it by using the algebra and math and geometry. All right. Okay. All right. So for the next one, We want to solve for x. Let me write it on the top of it real quick. Okay, so we want to solve this for x. Am I doing math for fun? Yeah, pretty much. But this is one of the problems that one of my tutoring students was having trouble with. So I just figured, I know they're not the only one, right? Okay. So what are they giving us? Okay, thank you, baby cheetah. So what are they giving us? So what is this something that they're giving us? Well, they're giving us an angle of 51 degrees. They're giving us another angle at 3x minus 6, which is an expression. And that contains the x that we're missing. Yes, so 3x minus 6 is an angle. Okay, they are giving us the angle of 51. Now, this angle, I'm going to try to, I don't know why I have so many of the same pens here. So the one, yeah, this side and this side. Okay. So this angle, 51 degrees, that's the inscribed angle. Okay. So if I take a look right here, that's my inscribed angle. So that means the arc that it's creating, how many degrees is the arc that it's creating? Okay. So if this inscribed angle is 51, what's the measure of the arc that's out here? Okay, so I got 102. Boost all sports 102. My sign person. Okay, because all we had to do is double the 51. So 51 times 2 gives me our 102. So if from here to here is 102 degrees, what's the measure of the arc out here? And how did you find it? Okay, so I'm seeing people saying, well, M is a right angle. How do you know M is a right angle? Is it giving us that indicator that M is a right angle? And inscribed means that the angle is formed inside of a circle. And it's not joined at the center of the circle, it's joined at one point, your vertex, on the circle. Okay? All right, so yes, this is your diameter, but it's not giving me any indication that it's 90 degrees. I don't know unless I'm doing the math, okay? So we're saying, I'm seeing 78s. How are we getting these 78s? How are we getting these 78s? Okay, so now we're saying it's 78, because, yes, Justin, yes. I don't know who the symbol is. Like, I wish I had names. All right, good. Since we have, and as someone mentioned, since we have the diameter, so that means this whole side of the circle is going to equal 180 degrees. We know part from here to here is 102, so 180 minus 102, that's how we got our 78. So if the measure of this arc is 78, what should be, how many degrees should this angle be? Okay, so I got a 39, a 39, not a 51, but a 39, 31. Okay. Yep, there we go. 39. Good. So this should be 39 degrees. And the reason why is because it's half its arc. So that means we can find x now, because we know that this is supposed to represent the measurement of that angle. So now, let me push up and slide over. So now we have 3x minus 6 is equal to 39. So now we can calculate what x is going to equal, because we're solving for x. So what does x equal? So L has 15. I think John said that earlier. Okay. And Al says 15. Ruth says 15. Something new. And on TikTok, wow. This is what happens. Okay. So 3x minus 6 equals 39. So we're going to add 6 on both sides. Okay. So that will give me 45. So 3x is equal to 45. Divide both sides by 3. And x equals 15. And since we're solving for x, that's where we stop. Okay, all right. There you go. Okay, and there was quite a few that were saying 11. Do we see why? And I think someone said, a couple of people said 17 as well. Do we see why now? Okay. All right. So we're taking what we know. And I think the reason why some people get that wrong is because they confuse the central angle with the inscribed angle. The central angle, as we mentioned earlier today, because I did come on here earlier, when it comes to the central angle, when your vertex is on the center of the circle, the measure of that angle is going to be exactly the same measure of the arc. And a lot of people carry that over when you see the inscribed. Okay, when you're looking at an inscribed angle, that means the vertex is not on the center, it's on a point on the circle. The measure of its arc is half. Okay, the measure of its arc is like basically double the angle, but the measure of the angle is half its arc. Okay, so we know we got to be cutting something in half. Okay. Oh, well, thank you. Forgot to add the 6 on the right side. Okay. Yes, that'll work. All right. So let's go with a couple more examples. Let me angle it. All right. So we have this lovely little circle. How did I get 78? Okay. All right, let me see. Hold on. How did I get 78? How did I get 78? Oh, okay. Angle. I was thinking, I'm like, 78 what? All right. So if we look, we got the 102 from our angle 51. Okay, I think you got that part right. But right here, that's our diameter because it's a segment that's going through the center of the circle. So this is half of the circle. So that means this arc here has to be 180 degrees because it's half the circle. So take the 180. Running out of room. I gotta get a bigger desk. So we'll get our 180 minus the 102, and we get our 78. So that's the measure of this arc right here. Okay, the whole thing's supposed to be 180. We got part of it that's 102. So what remains is this part, and that's our 78. Okay, awesome. All right. So now for this one, okay, again, let's solve for x. I'm going to write on top, so give me one moment. Okay, we're going to solve for x. What do you see? Okay, what do you see? Okay, you see a right angle or angle? I know I do the same thing with between angels and angles all the time. Now, where is that indicated, Justin? Okay, are they giving me any indications that I have a right? Okay, do I see that box at the S? Because if you don't see the box, you can't assume. Okay, you can't assume. So yes, we are solving for x. Yes, it is. So there's 5x plus 13. That's the measurement of STR. Yes. Just because it looks like, that's the one thing about geometry, it looks like a right angle. I can even sit here and say, oh yeah, that looks like a triangle. But with geometry, you have to prove it. You can't trust your eyes when it comes to geometry. I know, it's crazy, but here we are. It's all about the numbers. Okay. All right. How would I set this up? Yes, Jonah. So 5x plus 13, that is our angle T. Ooh, good question, trainer. Okay. This 12x plus 8, that's representing the measurement of this arc. So we got the measurement of the arc, which is your 12x plus 8. And then they gave us the angle. Just so y'all can see it, because sometimes it's a little hard to see it. Okay, so they're giving us this. I ignored you. How can I ignore you if I don't see you? I can't ignore something I don't see. I didn't ignore you. Was it a plot for me to go searching for you? I said it, but you didn't say anything. Did you? I don't see anything. I just see your stuff from the last answer, Lisa. Maybe it's just not showing up on my computer screen. If anything, type it in again. Okay, arc length, not the outer angle. It's arc measure in degrees, not length. Yes, this is definitely the measure. It's not the degrees. So we're not looking for arc length. We're not looking for sectors. We're looking for the measures. All measures. Okay. Ew, rude, Addie. Try that again. Try to figure out a nicer way of putting it out. Because, yeah, I don't do well with rudeness at all. I've been in the classroom for 22 years. I will shut somebody down. Because right now, this is supposed to be my rest time. And and it triggered. She's like, just do it already. And I'm like, this is supposed to be you guys trying. This is the first one. That's got me like, okay, all right. So I'm waiting for Addie to try to find another way of asking. And then I can get started. I know. I feel like I'm giving the look. You know, that teacher look? Yeah. Okay. Ninth grade geometry? It's geometry. Not so much like... She left? Oh, heart broken. Okay. All right. Not a problem. Thank you. All right, so we know that the measure of the arc is going to be twice the measure of the angle. So the best way to do it is we could either take half of this arc and equal to the angle, or we can double the angle, make it equal to the arc. That choice is going to be up to you. So if I do 2 parentheses 5x plus 13, if I double it, it's going to equal the measure of the arc. Let me zoom a little less so we can all see. Okay. So when we do this, okay, so when we do this, now we can do the distributive property. Let me use different colors so you can follow along a little bit easier. So 2 times 5, that gives me my 10x. And 2 times 13, that gives me my 26. Then I bring everything else on down. Yes. So you can say, you can either double the angle to make it equal the arc, or you can take half of the arc to have it equal the angle. Okay. So now, we want to get our x's to the same side. Really doesn't matter what side, but if you want, we can subtract the 10x. If you want to keep everything positive. If I'm moving my x's to the right, that means I need to move this 8 to the left. You can do all this in one step. So when I move my x's to the right, they cancel out, leaving me with 12x minus 10x, which gives me 2x. And by me doing that, that means I have to subtract the 8 on both sides. So now I got 26 minus 8. That gives me 18. Because these will cancel out. And these will be 18. So now all I have to do, divide both sides by 2. So now my x equals 9. Okay. All right, so we got a couple of questions. Let me kind of go back. All right, Austin, how did you get the 2? Because twice the angle equals the arc. Okay. If I wanted to, I can go the other way. So I'm going to just kind of slide this over a little bit so you guys can keep with this. If I wanted to, I could say, all right, well, let me keep the angle, which is at 5x plus 13, and have that equal half the arc, 12x plus 8. Okay. If I wanted to do half the arc, well, this will give me 6x plus 4. Then I bring down my 5x plus 13. And then I could have subtract 5 on both sides, or 5x. And with me subtracting the 5x, I could subtract the 4. Okay, which will cancel out the 5s, cancel out the 4s. So then over here, I will have x. And then when we have 13 minus 4, will give me my 9. Okay, so either way, you're going to get that same answer of 9. Okay. All right. You're welcome. I appreciate that. Okay, so let me see approximately what grade level this is. Well, it's geometry. Could be 9th or 10th, depending on what state and what district you're in. Because my district's thinking about changing everything, so who knows? It might be Math 1. Never know. Technically, it should have that degrees and the same with that degrees. it should have 12x plus 8 degrees, and the same with the 2 came from the, oh, okay, you're explaining where the 2 came from. Okay, got you. Because I was like, they're not going to be the same. Okay. Just divided the 2 to both sides instead of distributing. You could have. Yep, you could have done that. I'm right on time. Good. I take my math GED. Okay. Nice, thank you. No problem. That's the last one. We have one more. Okay, oh my gosh. I despise geometry. Oh, that's all right. What is that? Swan? Could you do a 3D problem math for 6th grade? Yeah, no. So we have one more. Okay, I'm going to leave you alone for this one. See if you guys can get that. Think about what we just did with the last one. Okay, again, we're going to solve for x. I'm just going to keep it simple. Okay, still going to solve for x. Okay, and this one definitely has to be my last one because I have a client at 2:15 and I would like to get something to eat before him. I don't want to be hangry and doing math. That's just not a good combo. Yeah, as soon as I'm done with this, I'm going to try to upload them, but it will be not like soon. I'm just kind of curious what you guys will get for x, okay? Oh, yeah. If anything, if there's like anything in particular, I think it's Kimmer. You know, I do tutoring. I mean, if anything, just message me and I'll see. We can work things out. Oh yeah. I know. It all depends on like how deep they'll get with circles. Especially when they spend so much time on one thing. I mean, like, it's nice to spend time that we're taking their time to marinate, but there's this one time we were working on something for like almost a month and a half because the teacher was absent and then they had meetings and holidays and I was like, when is this unit going to be over? You don't even have to go through all that. Just really take a look. Take a look. Take a look. What's happening here? And we're solving for x. We're solving for x. Okay. No, it's not arc length. We're just doing arc measure. Arc length and arc measure, two separate worlds. No, they're not going to be equal to each other. Because they're not vertical angles. but there's something. There's little bits and pieces of things that's like little mini clues. Angle B is an inscribed angle. Michael. That's your final answer? Indefinitely amount of solutions. I know. We know you're cool, Michael. We know. Okay, so I saw a few answers. If anyone else has a couple answers, and I also will take question marks. Okay, also take question marks. Okay, so if you're not sure, it's okay. Put some question marks up there. Thank you. Thank you. Thank you for your honesty. Because that's the only way that you're going to learn. Okay, don't let your egos get in the way. And if you're thinking you got an answer, be proud of the answer that you have. And if it's wrong, we make the adjustments to it. If it's right, it's awesome. All right? Okay. So now, we have A to C. It's going through the center of my circle. So that means we have a half circle. We don't need to worry about the measure of the angles because what they're giving us is our two arcs. That equals that half circle. So let me unzoom a little bit. I can hear everyone, oh! Everyone's like, wait a minute, I think I get it. Don't do it yet. No, I'm going to just set it up. Go ahead, you rapid response. So we have our 10x minus our 6. Instead of having them equal to each other, they're actually going to be added to each other to equal 180. Both of them are arcs. Now, if they ask me to find a particular angle, then yeah, we have to solve for x, plug it in, and then we can find the particular angle. So now from here, combining our like terms. So we have our 10x and our 4x, which gives us 14x. And then we have our negative 6 plus 18. That gives me a positive 12. Equals 180. So now from here, we want to subtract 12 because we're trying to solve for x. So we have our 14x is equal or 168. Then here we can divide both sides by 14, which gives me x is equal to 12. Okay. All right. Boom shakalaka. All right. So, devil's advocate, let's find the measure of these arcs. And I'll eat sometime today. That's how time just goes by. So, we know 10 times 12. Let's find the bigger arc first. So we know that 10 times 12, that'll give us our, and then subtract 6 from that. From the beginning. You probably did, I know. All right. What is the unit of x? I don't know, you tell me. What's the unit of x? All right, so now that we have our 12 times 10, that gives me 120. 120 minus 6 gives me our 114. Good, nice, Michelle. So if that's 114 and this whole thing, or this arc, is supposed to be 180, so what's 180 minus 114? Not 64. 60 something, but not 64. There we go. 66. There we are. All right. So if this arc BC is supposed to be 66, what's the measure of this angle BAC? Okay, so if arc BC is 66 degrees, what's the measure of the angle BAC? Okay, Michelle, my mom. Hey, Tiffany, I didn't see you sneak in here. Symbols, 33. So it's not going to be subtraction, Roy. In 2 scoops, we're taking half of 66. You take half of it. Okay, take half of it. Because this is not the central angle. If it was a central angle, it would also be 66. It's an inscribed angle. So the angle's all the way in the back. Think of an eyeball, okay? We're all the way back here. So right now, you're taking the measure of the arc and you're dividing it by 2 to find this angle measure. Yeah, so it's going to be 33. Haven't done it in years, right? Bringing it back. All right. So we know the measure of, awesome. So we know the measure of this arc was 114. What's the measure of this angle ACB? What would be the measure of, I'll change colors, of this angle? What would be the measure of this angle? So you guys can see. It's another way for us to redeem ourselves. What would be the measure of this angle? If its arc was 114, the measure of this angle will be what? There we go. So 55, good. Your mom, good. Lend me a queen. Yes. Good. I think there's like a delay or something. Good. So that's 57, right? So what will be the measure of angle B? All right. What would be the measure of angle B? Okay. Your mom says 90. Michael says 90. Leon says 90. Let me your queen. Yes, Michelle says 90. That says 90. Okay, good. Only way we can tell, I know it looks like a 90-degree angle, but if you got your 57 plus your 33, That gives you 90. Okay? The sum of the interior angles of a triangle always equals 180. So 180 minus 90 gives you 90. So I'm just going to put my little box right there. All right. Awesome sauce. Okay, so I'm not sure if people are there yet or they're about to get there, but that's how you solve. That's the difference between the central angle and the inscribed angle. All right, so for later on, because I have to get going. So for later on this evening, we are definitely working on logs and exponentials. No excuses. And I think I might be coming on a little early because my 7:30 kid canceled on me. So, and I already got it all ready for us. I got it ready. It's just need to just do it, right? That's all I need. It's been sitting in this book for a long time. And for those that actually enjoy my books series, okay, this is my math notebook. I actually created this for us to get some formulas on the side, some of the steps. Okay, if you ever have any kind of worksheets or anything else that needs to be dealt with, dealing with the graphs, you can get your own copies through Amazon. I'm working on doing self-publishing as we speak, but for right now, you can get your copy through Amazon. If not doing the math, we also have factor sheets in there and also some of the rules and regulations that we all have seen and dealt with. When it comes to a little bit of geometry, a little bit of algebra. So if you like it and you want to purchase your own book, that'll be awesome. Go ahead and go on to Amazon. You can also get the link in my bio, which is through my website. And if you want any tutoring sessions, just let me know. Okay, go ahead and message me and we can do that. All right. Now, go ahead and venture. If anything, go to Impact Math 19. If you want to do some more math, she's doing the math with some GED as well as ASVAT just to get you guys ready. And I will see you guys this evening if you want to come back at 8:30. All right. Have a lovely night. Looking forward to logs. Yes, we're going to start at 8:30 tonight. Okay, 8:30. I'm going to see if I can put a post out there just as a reminder. All righty. Okay, see you guys. Love you. Bye.